Let's find the linearization L of x of the function at a. So the value is given, and this is kind of a simple practice problems based on what we have discussed in the previous video about linearization, what it is and how to solve it. So before I start solving it, let me just do a quick reminder of what we learned in the previous video about linearization. So linearization is equal to, how do we find it? The starting point, the value of this function at a given point. So f of a plus the slope, the derivative of the function at the given point, multiply by the distance, where we at and where we're trying to reach, how far we moved horizontally, x minus a. Okay, so here we have the equation linearization. Let's find out how to solve it. Looking at the first problem, f of x is equal to this function x cubed minus x squared plus 3, and a is equal to negative 2. So let's just solve for what we need in this linearization equation here. So f of a is negative 2. The value of this function at negative 2 is negative 2 cubed minus negative 2 squared plus 3, which is equal to 2 times 2 is positive 4 times negative 2 is negative 8. And negative of negative 2 square is positive 4 plus 3, which is equal to minus 4 plus 3, which is negative 1, so it's negative 9. Okay, so we have the first value here. Now the next thing we have to find is f dash a, the derivative of this function at value a is equal to negative 2. But we have to take the derivative before we start plugging in the value, right? So the derivative of this function f of x is power rule, right? Bring the power in multiplication and then subtract minus 1 from it. So 3x squared minus 2x plus the derivative of constant is 0. So this is what we have here, f dash x. Why we had to solve it? Because we need the value of this function, the slope, right? So f dash a is negative 2. Let's just plug in the value here now. 2 times negative 2. So negative 2 times negative 2 is positive 4 times 3 is 12. Negative 2 times negative 2 is positive 4, which is equal to 16. Okay, I think we have everything now, right? So let's just plug in the value here. The linearization of the function at a is equal to f of a, which is f of, you can write as this first so you don't get confused, plus f dash of negative 2 times x minus minus 2. Make sure you're paying attention to the signs. So this is equal to f of negative 2 is negative 9 plus derivative slope is positive 16 multiply by x plus 2. So this is equal to negative 9 plus 16x plus 16 times 2 is 32. So we have L of x is equal to 16x. 32 minus 9 is 23. This is your answer for this one. Let's look at number 2 now. Same thing, right? Let's and please try to solve it before I finish solving it. So this way, it's better to see if we really get the concept or need more guidance. Okay, simple as it is, right? So first plug in the value, find the f of a, right? We can just also write as such this, which is simply plug in the value, and we know that it's 2 times 2, right? Everyone knows this, but I'm just trying to simplify again to see how we actually get it. So it's 2. Now we need the derivative, right? For the second part, f of derivative of this. See, first I would like to write in the simpler version so I can see clearly. Okay, power rule is being applied here without getting confused with the square root. So this is equal to, bring the power down, subtract minus 1 from it, which is turned into negative, right? So this is the derivative we have, and then we have to find the value at 4, which is simply 4. Same thing, right? Square root of 4 is 2, which is equal to 1 over 2 times 2, which is equal to 1 over 4. Third, we just gonna plug in the value there in the equation. So linearization of this function at a is equal to 4 is f of 4 plus 4 times x minus a, 2 plus 1 over 4 times x minus a is 4. So this is equal to, okay, 2 plus 1 over 4x minus 1 over 4 times 4, right? So this is simply negative 1 here. So we have 1 over 4x plus 2 minus 1, and L of x is 1 over 4x plus 1. Next is find the linear approximation of the function at a is equal to 0 and use it to approximate the numbers square root of zero point 0.9 and square root of 0.99. So again, this is part of the previous video what we have discussed, the main reason we where does the linear approximation plays its role, right? Like when we don't have a calculator, how do I know how to can you calculate, do you know right now of what is the square root of zero point 0.9 or 0.99? No, I honestly don't know without calculator. And so let's use this linear approximation equation to find that without calculator. So this is fun, right? Again, same thing, right? We are familiar with the linearization equation that we have just discussed previously, few minutes ago. But we already know we're at the starting point f of a, and then take the derivative and then find the value at that point, multiply by how far we are moving. Okay, let's do exactly what we have done previously. So f of x is square root of 1 minus x. A is 0. So f of 0 is equal to square root of 1 minus 0, which is square root of 1, which is 1. Derivative of this function is, again I would like to write this as this, which is equal to, bring the power down, square root of 1 minus x, because subtracting minus 1 from the power gives us back negative of 1 over 2, which is again, if you bring down it becomes positive. So this is what we have, and then the value of, okay, so if you already reached this point, then I would say stop it. You are making the most common mistake here. this is the derivative of this function. Are you sure this is the correct derivative for this function? Is there something else we're supposed to do here? I think we all agree we do, right? Since this is the inner function now, we have to take the derivative of the inner function as well. You can't just leave it, just take the, or you can't just apply the power rule here, correct? So you have to take the derivative chain rule here, right? You can, just let me know in the comments if you want me to simplify and explain it step by step. But I have done previous multiple videos about chain rule as well. It's pretty easy. Okay, it's just a matter of finding the derivative of both the inner and the outer functions, which in this case becomes square root of x, the outer function, where x is equal to 1 minus x, and then inner function is obviously 1 minus x. And when you take the derivative of this inner function, derivative of one constant, it's 0, minus derivative of x is 1, right? So this is going to be negative 1. And the derivative of the function f of x is negative 1 over 2 square root of 1 minus x. And now the derivative of at a, which is equal to 0, is simply going to be negative 1 over 2 square root of 1 minus 0, which is again 1 over 2. Square root of 1 is 1, so simply negative 1 over 2. Okay, so we have found what we needed, f of a, which is equal to f of 0, f derivative of f of a, f dash prime, f prime, my bad, sorry for always saying dash instead of prime. Let's just find the equation now. So L of x linearization is f of a, which is 1 plus slope derivative is negative 1 over 2. If you are forgetting this, then the whole thing is off. So you have to pay attention to the derivatives now. You won't see apply chain rule, apply implicit differentiation. You just have to know now by this time, unless it's physically mentioned. But otherwise, you have to pay attention to all the concepts yourselves. Multiply by x minus a, which is 0. And x minus 0 is still x, so L of x equation we have is 1 minus 1 over 2x. Okay. So find the linear approximation of the function at a is equal to 0. We have done that already. The next part is use it to approximate the numbers. 0, square root of 0 0.9 and square root of 0 0.99. See, we are trying to find now without calculator. And we have the equation already handy. So we know that x is equal to 0 0.9. So if you also think that x is equal to 0 0.9 here, okay, no, we need to go back to the previous video about linearization. Pay attention here. Why this is not x? This is, we have this function f of x given, right? 1 minus x. And we are trying to approximate the numbers of this square root of 0 0.9, square root of 0 0.99. So we already know that this f of x, this function is equal to now 0 0.9. And we are trying to find the approximate value for this square root. So we need to find the x that makes this function equal to 0.9. So 1 minus the value of x, which in turn returns 0.9. And how do we solve that? Let me make more space here. Okay, so we already have the equation here now, and now we are trying to approximate the numbers of square root of 0.9. But based of our equation that we are going to use, so this is approximately equal to 1 minus 1 over 2 times x, which we are trying to find, because we know that this is the function we are trying to find the value for. So we have this function square. How the easiest way to find is just put these two together, right? Because we know that this function is equal to now, sorry, 0.9. So square square cancels out. So we have 1 minus x is equal to 0.9. And so negative x is equal to 0.9 minus 1. So negative of, this is 1.0 minus 0.9. So 10 minus 9 is 1. Negative of 0.1. So this is positive. Negative, negative. So we have that x is equal to 0.1 here for this function. So now we can approximate the value for this function, which is approximately 1 minus 1 over 2. Or you can just simply write this as x over 2, right? Multiply by 0.1, which is approximately equal to 2 minus 0.1 divided by 2. So square root of 0.9 is approximately equal to 2 minus 0.1 is what? 10 minus 1 is 9. So we are left with 1.9. 1.9 divided by 2, which is approximately equal to, so 2 divided by 1.9, 2 times, no, okay, 0. We have 9 to the 18. 9 minus 8 is 1, so we have 10, 5. 2 5s are 10. This is approximately equal to 0.95. And that's how we calculate this without calculator. Now try to calculate this for the next function yourself. We already know that this is the function. For example, as f of x is square root of 1 minus x, so this is like, this could be anything, right? 0.293949, and we just need to, if you simply if you think that x is 0.9, then 1 minus 0.9 is, that becomes something else. That's not what we are trying to find for this question. We are just asked to approximate these numbers, and that's how we find the x and simplify this. So again, just plug in the numbers here, right? So 1 minus x is, what is x now in this case? Again, so square root of this function, we already solved this, right, up to here. But now we know that x is equal to 0.99. 1 minus 0.99. So 1 minus 0.99. So 10, 1, 0, 0. We have 1 minus 0.01 divided by 2. So this is equal to 2 minus 0.01 0.01 divided by 2. 2 minus 0.01, which is equal to 1.99. 1.99 divided by 2. So 2 divided by 1.99 is 9 to the 18, 5. So square root of 0.99 is approximately equal to 0.995. Now you can always pick your calculator and see if this is exactly what we are getting. So I'm gonna check real quick. Based off calculator, square root of 0.9 is equal to 0.94868. So yeah, pretty close, pretty darn close. So good. Square root of 0.99 per calculator is equal to 0.9949874. Pretty darn close as well. If you'll be amazed to see. This is a great concept to know or get yourself familiar with. Amazing. So yeah, I hope this all makes sense. Thanks so much for watching.